I will basically present our so-called EPES slang, which we developed in the EnergyShield project. Okay, as Eric already gave some short introduction, we develop a MAL language, meta-attack language. So, and the EPES lang we use is basically comprised of 3 different parts. On the one hand side, we have the classical IT part, everything you know from your office. Then we have the OT part, which is running to manage, for example, the substations. And then we have a concrete substation part which is inspired by the SCL definition. And before we will dive into more technical details, I will just give you some overview of how the single parts of these languages look like. What you see actually is the core lang, we call it, because it's somehow representing everything you have described in your IT. The most important part is here in the middle, more to the right, the system parts, where we have our applications and systems and some kind of physical zones. Basically, applications describe everything from which is programmed. So from the operating system to the web browser, or what's also running in the web browser. So you have some kind of layered architecture here. Then we have, of course, something like networks. I have also a pointer, I guess. Yeah. Here a network. So stuff like the applications are talking to each other, and yeah, some firewalls in between, and some kind of connection rules of data which is allowed to be transferred between them. And there we are directly at the next point, our data resources, where we have data, which is the things that are in transition. So sent between applications, but also stored in databases, for example, like credentials. Basic thing to, for example, log into an identity in a system or an application. And then we have also some kind of vulnerabilities and exploits that can be used to get access to your system and do the things a hacker likes to. So this is the IT part, and it has shown that it's a good way to represent the IT. Coming to the OT part, I'm not quite sure who's all attending, but if you are working on cybersecurity, you might be aware of the MITRE attack enterprise metrics. And recently, early in this year, MITRE has also released such a matrix for industrial control systems. Basically, they have some kind of techniques identified and some kind of assets you usually have in your OT environment. And yeah, they have characterized different attacks that are possible on those systems. And we took these different attack steps and created from this the so-called ICS lang that represents our OT environment that we can model later in securiCAD. This is a little bit smaller than the IT assets we have found, but basically we have still some kind of network, which is a little bit more special than the IT one, as we have some kind of special OT network protocols. Then we have some security assets, like also some kind of firewalls between the different networks we have in our OT environment, and some kind of antivirus. And then according to the Purdue network framework, we have level 1 and level 2 assets, where level 2 is closer to the end user. Yeah, so you can say end user, where we have the HMI, where the the operator is interacting with the system. We have the data historian storing the information and what happened in the SCADA environment. We have engineering workstations to make changes to our systems. We have control server controlling the controllers, where what we are doing on the engineering workstation is deployed. And then we have on level 1 the stuff which is interacting with the actors. So the controller basically and our safety systems. And yeah, in our EPES lang, which is comprising all those parts I'm presenting, we link these languages to each other. So we have on the one hand side the IT and we have the OT, and we link them to each other so that in our later threat model we create, we can traverse from the IT level to the OT level. And finally, I promised the SCL lang. And this is a very concrete language developed by a colleague of us. She's working on substations, and she formalized the description of SCL to a MAR language, which is also then linked to the OT level. So this level is operated by the OT level, and therefore we have also mostly the links from the controller to what we can see here. But I don't want to go deeper into this. That was a lot of theory and nice looking pictures, and therefore I want to show you now some real source code so that you can grasp how we work and how it looks like what we're doing. Here you can see some real MAR code that we use to create the models we are then using in securiCAD. Basically, we have some category, which is just for categorization stuff, so visualization. And then we have an asset called firewall, which we use in our between our networks to control the traffic in between them. You might remember it from the ICS lang slide. Having a closer look at the source code, the one important thing what we have are these attack steps, which are, if you're talking about attack trees, our single nodes. So you can give them names as you like to, for example, access, which will allow you later to use other attack steps like a commonly used port, or as we are on the firewall, bypass the firewall. Here the pipe tells us that this is an OR attack step, meaning that all incoming steps to this access, so every time where access is written after this arrow, it is just necessary to get one of these attack steps to get to this one. We have also end attack steps, meaning that every attack step needs to be compromised before we can take this one from to exploit it from the attacker. What you also can see is something like that we can give distributions, meaning describing that here an attacker will need an exponential distribution with an average of 3.5 days to use this attack step called commonly used port bypass IDS. So we have an IDS maybe in place, and we want to bypass this while we are elaborating on commonly used ports. So like AT&CK for Tomcat. And this is also something which is backed by some kind of research former colleagues of us did. So if we already have the information, we are putting them there. For example, we have also some information on how much time people spend to bypass a firewall. And then you might have recognized here the hashtags that are describing defenses. So for example, if you put a whitelist into place, then commonly used ports are defended. So leading So basically, this attack step is then blocked, and the attacker cannot succeed here further. So he has to search for another way. Yeah, and basically, then this is how MAL languages look like. Additionally, as I said, we are based on the ICS metrics. We put also always the information there which tactic we are representing. Okay, now we can take a closer look how it will look like in securiCAD. Let me share my screen. So this is securiCAD. Eric showed another version of it. This is the standalone one. Basically, so we have now described our MAL language. However we did it, we don't care anymore. And based on this, we can have a compiler and compile jar files that we then can use in securiCAD to get our own set of assets. So in the version Eric showed you, you had some kind of standard IT assets that are usually used in the context of securiCAD. But as we are working on a concrete domain, we decided to have a MAL language, and therefore we created the MAL language and also these assets. For example, here we can see the firewall that you saw in the code before. And then the modeler can take all these elements and model the network or their environment they also already have around. So they can do simulations on what they have around. What you can see here now is a small example that represents the Ukrainian scenario from 2015. Maybe not everyone is aware of it. In 2015, substations or DSOs in Ukraine have been attacked by most probably Russians. And they were able to take over the system and switch off the light for 250,000 Ukrainians around Christmas. And this was the first really documented attack on ICS systems where civilians were involved. Up front, we had the attack on the Iranian atomic program, but this was clearly military working on this and to harm also military. But here it was the aim to harm civilians. Basically, you can see here the attacker also doing some kind of, so we linked it to the user, so doing the phishing attack. Basically, the attacker sent to some users in Ukraine a Word file with some information. Yeah, please activate this macro. This macro was including some code called Black Energy. And this Black Energy code, when you activated the macro, allowed to take over first the Office version you had and also the Windows, and gave you full rights on it as you were able to execute any code you wanted to have. And then the attackers were able to go through the entire network. So here we have some Windows 7 machines with some exploits possible, zero-day exploits or whatever. And basically in the documented scenario, somehow the people were able to gather VPN credentials, and using them, they were able to go to the next, to the OT environment. For example, here we can see we have the VPN credentials stored here, but not the client itself. The client is on this application here. But they are using also different credentials, but due to the VPN credentials, the attacker got access to the OT environment and to the HMI. There, basically, they used the remote desktop function and just clicked on the screen and opened switches that led to the power outage. Yeah. But to be more detailed, we have also added some data historian here. Eric also talked about it before, which is working in a DMZ between a firewall. So we have a firewall in between to the OT network. And in our OT network, we have a control server controlling our controllers, and also a firewall to our substation. In the substation, we have an I/O server and controlling different controllers. And they are, if you control the controllers, then you can do whatever you want. So that's basically the path described the documentation to this attack. Now we can start some simulations. Basically, our attackers want to do some physical damage, impact. And here we can also see that in 100 days, the success rate to come to the controller to physical impact is about 30%. I already did the simulations for this. Apart from that, we can also have a look at the critical path, what we will do now. Share screen. Which gives us this picture. We can see here the attacker, and that he phishes the user, takes over the user account, and then he's traversing from Office to the Windows machine. Then he gets access to the network, and it's going down the entire way until he has access to the controller and gets physical impact. So this is the critical path. This is the easiest one. So if we increase the level of detail, we can see that, okay, this is the critical path also described in literature, but there are also other ways, for example, using the data historian. It's here. So this path is using the data historian and getting then access to our OT network. And what we can also see is that if the attacker made it to the OT network, he is or she is able to almost do everything, which is also something I got from discussions with practitioners. They said, okay, if an attacker makes it to the OT network, then he's able to do almost everything he wants to.